Okay, today we are looking at mixture problems in Algebra 1. Mixture problems can be very difficult if we don't set these up right. So as we get started on these, we want to make sure that we do set all these up right. Yesterday, as we looked at distance equals rate times time equations, we had to spend a bunch of time setting up the problem and make sure we had it set up right. Today with mixture problems, it's the same deal. We got to make sure that these problems are set up right. I'm going to do a couple problems off the homework tonight. First one is I'm going to look at number 3 on page 111. So here we go. We're going to read the problem and figure out, we're going to make a chart, and we're going to get this thing going. Okay, here's the problem. A scientist wants to make a solution that is 30% acid using one solution that is 50% acid and another solution that's 20% acid. How many liters of each solution does the scientist need to make 75 liters of the mixture? Copy and complete the table below. Alright, here's the deal. We're going to take a 30% acid solution, mix it with a 50% acid solution, and sorry, that's not what we're going to do. We're going to take a 50% acid solution, we're going to take a 20% acid solution, but we want to make a 30% acid solution. Here's the whole deal. We're going to take a 50%, we're going to take a 20%, we want to make a 30%. Does this make sense? Is this possible? If I had this chemical A, which is 50%, and this chemical right here, which is 20% acid, could I pour these into this bucket down here and make a 30%? Yeah, that should make sense. Which one would I need more of? I think I'm going to need more of this guy. I should need more of the 20% since 30 is closer to 20. I should need more of this 30%. We're going to go ahead and solve this problem. We're going to use the table. I'm going to set up the table just like the table in the book. And we're going to start this thing. So here's the deal. I know what I'm going to mix together. I'm going to take a 50% acid solution with a 20% acid solution. Here's my two solutions. And I want to get my mixture to be 30%. That's the idea. This, I'm just setting up the problem. I'm not even actually making the table yet. Here's my table. I just want to make sure that I know what I'm talking about and which ones I'm looking at. The next thing that I want to do is I want to figure out how much of this am I going to mix. What's the concentration? Well, these are easy because they already told me. And what's the total going to be? And total, I'm just going to multiply the amount times the concentration. And that should give me the actual, it'll give me the amount of acid. I'm just going to call this a total for now, just to kind of make my, kind of keep track of things. So, concentrations, let's fill in what we know earlier. What's a concentration of a 50% acid? 50%. That should be easy. And if things are easy in this, keep them easy. Don't make things harder than they should be. What's the concentration of a 20% acid solution? It's 20%. It's from right there. The concentration is 20%. Following the same pattern. If I have a 30%, or what's the concentration of a 30% acid? 30%. We're just going to go with that. Those numbers should be easy. We can deal with that. The harder part is this, the amounts. So I'm going to read this problem again. A scientist wants to make a 30% acid solution using one solution that is 50% acid and another that is 20% acid. How many liters of each solution does the scientist need to make 75 liters of the mixture? Okay, I want 75 liters of this mixture. That's an amount, 75 liters. I want 75 liters of this. So I'm going to put 75 in there. That's how many liters I want. The problem is it doesn't tell me how much I have of this or of this. So I have to be clever and think about this. I have to be able to use a variable. Do I know how much of the 50% I have? No. If I don't know, I'm going to put a variable. Do I know how much of the 20% I have? No, I actually don't know that either. I don't want to write another variable though. What I want to do is figure out some relationship between this x and this 75. And here's how we think about it. If I have 75 liters total, here we go, I have a bucket. It has 75 liters in it total. Here's all 75 of them. And I tell you that from here to here is x, that's the x. How much could you figure out is in here? What is this part right here? What is this area? If the whole thing's 75 and this little part's x, what is this area? Well, this would be easy if I said x was 10 and you tell me that's 65. If x is 20, you tell me that's 55. If x is 30, you tell me that's 45. So let's keep it simple. What'd you do? You did 75 minus x to get the other part. So to get the other part, 75 minus x. What are their totals? I'm just going to multiply each of these. 50x, 20 times 75 minus x, and 75 times 30. And there's my totals. Now the table, that's the hard part. The math should be the easy part. I know I'm going to mix these first two things together. I'm going to take the 50x, which is the 50% solution. I'm going to mix that with the 20% solution, which is 20 times 75 minus x. And I'm going to get my mixture, which is 75 times 30. Okay, now it's just easy math. It's algebra. This is what we do. This is how I know how to do. 50x plus 20 times 75 is 1500 minus 20x equals 75 times 30. That's a little bit harder to do in the head. 2250. Alright, now we're going to combine like terms. 50x minus 20x is 30x plus 1500 equals 2250. Subtract 1500 from both sides. 30x equals 750. There's my table if you want to see it again. That's where all those numbers came from. 30x equals 750. Divide both sides by 30. X equals, those are gone. 3 goes into 75. How many times does 3 go into 75? 3 goes into 75. We'll actually work this thing out. It's going to be 18. Let's see. 3 goes into 7. Twice 6, 1, 5, 25. Oh, I don't know why I made that so hard. X is 25. Okay, the question asked, how many liters of each solution do I need? I know X is 25. So if I go back up here, now I know that X is 25. I have X is 25, so the 50% solution, I have 25 liters. And of the 20% solution, it's just 75 minus that. 75 minus 25 is 50 liters, and there's my other answer. 50 liters, 25 liters. If I mix those together, I have 75 liters. There we go, easy money. Let's try one more of these. These do take a few minutes to do. Let me remind you what we just did actually. We're going to take the concentrations because they gave us each of those. We put each of those in our table. The amounts, it gave us one of the amounts. We have to be clever to figure out the other two amounts. We're going to make one of them a variable. We're going to figure out the relationship on the other one. Multiply those together. We're going to add the first two things that we're mixing to get the mixture, and it's solving an equation after that. At the very end, make sure you're answering the question that they wanted you to answer. We'll go look at another problem now. I'm going to look at let's look at number 5. We'll look at number 5 and get another table set up. So come over here, read number 5, and we'll get this one going. And you could be looking at this in your own book. It's probably going to be easier to read. Number 5 says a chemist needs a solution that is 75% acid, but only has solutions that are 35 and 85% acid. If the chemist measures 120 milliliters of the 85% solution, how many milliliters of the 35% solution should she add to make a 75% solution? Okay. What's going on in this problem? I'm going to mix a 35% solution with an 85% solution. Excuse me. And I want to get a 75% solution. I have a 35% solution, 85% solution. I want to mix them and get a 75% solution. Which one am I going to have more of? Hopefully that's an easy question. Which one do I have more of? 85%. I should have more of this. But that's just an aside, and we're not too worried about that right now. Okay, make a table. It told us, well, here's our concentrations. What's the concentration of this acid? 35. What's the concentration of this acid? 85. What's the concentration of this acid? 75. That is the easy part. The harder part, what's the amount that I have of each one? Well, it told me in the problem that I have 120 milliliters of the 85% solution. There's 120 milliliters of this solution. What do I do now? Well, I'm going to make one of these a variable, and look, I'm going to make that one a variable. I made the first one a variable up there, I'm going to make this one a variable here. If I mix X milliliters of this with 120 milliliters of this, in my little jar over here, here's the X, here's the 120. How much do I have total? Well, I'll just add those together. That's how much I have total, 120 plus X. Does this make sense? That's an X plus 120, I have 120 plus X. Total over here, I'm just going to multiply each of these things. This is 35X. This is 120 times 85, and this is 120 plus x times 75. And there's my totals. My totals is what I'm actually going to use to write my equation. I'm going to say 35x, which is this guy, plus 120 times 85, since these are the two things I'm mixing. And I want to get my mixture, which is 120 plus x times 75. Now as an equation, distribute, combine like terms, collect like terms, and we can solve this thing. So I have 35x plus 120 times 85. Let's figure out what that is. 120 times 85. 0, 0, 1, 5, 6, 0, 0, 16, 1, 8, 9. This is going to give us 0, 0, 2, 10, 10,200 equals, when I multiply these guys over here, I know 75 times x is 75x. I don't know what 120 times 75 is, so I'll do that real quick. 120, 75, 0, 0, 1, 6, 0, 0, 4, 1, 7, 8, and this will take me to 9000, 9000 plus 75x. I can solve this thing now, subtract 9,000 from both sides. That will give me 0, 0, 2, 1, 1200. And we subtract 35x from both sides. 1200 equals 40x. Divide both sides by 40. X equals, zeros cancel out, 120 divided by 4. Well, 12 divided by 4 is 3. There's another 0. So that must be 30. X is 30. These were milliliters. What did I just answer? X tells me how much of the 35% solution I needed. Check this out. Here's the X, 30 milliliters. Here's the X. There's 35 milliliters of that guy. What did the question ask for? The question asks for how many milliliters of the 35% solution did I need to add? Well, 30 milliliters. If you want to figure out what the 75% was, you could do that. It would just be 120 plus x. So this number, if you want to figure out this one, 120 plus x, would be 150. This one was 30, what we just found. 30 plus 120 is 150. And we've solved that one. These are the two problems off your homework. This actually is questions 5, 6, 7, and 8. And that was question 3. So we've done 3, 5, 6, 7, and 8, and that's the rest of your homework. So we did all the other questions in class.